Hey everyone. So let's talk about robots. Now, when you hear that word, your mind probably jumps straight to sci-fi, right? Futuristic stuff. But what if I told you the real story? The journey to create these machines is actually one of the longest and, honestly, one of the most fascinating stories in all of human history. We're going to explore that long road, the one that got us to where we are today.
And you know, to really get where robots are going, we first have to stop and appreciate something they've already done. Something that's, well, it's just mind-blowing. Our story today actually begins not here on Earth, but about 34 million miles away, on the silent, red surface of another world. Just look at this picture. This is it, the very first photograph ever taken from the surface of Mars. And get this, just minutes before this image was snapped, a machine, NASA's Viking 1 lander, pulled off a perfect, fully automated landing. I mean, just think about that for a second. A robot flew itself across the entire solar system, slammed into the Martian atmosphere at more than 20 times the speed of sound, popped a parachute, fired its own landing rockets, and just set itself down, all on its own.
So yeah, a picture like this, it just begs the question, right? How in the world did we get here? How did we, as a species, create a machine so advanced it could literally act as our eyes and our hands on a totally different planet? Well, the answer isn't some single brilliant invention. It's actually a story about a few ancient dreams finally coming together.
Okay, so let's break this down. The first piece of the puzzle is the body, the physical machine. And this part of the journey, wow, it took thousands of years. It really started with one of the oldest dreams we've ever had, making something that's not alive move, all by itself.
And what's just wild to me is the sheer scale of time we're talking about here. I mean, the dream itself, that starts way back in ancient Greece over 2,400 years ago, with things like little steam-powered birds, just cool novelties. But it wasn't until the 1600s. Think about that gap. That brilliant minds like Galileo and Newton finally gave us the science, the actual rules for how things move.
And this was the breakthrough. Sir Isaac Newton's laws. They were like the owner's manual for the physical universe. For the very first time, motion wasn't some kind of magic anymore. It was math. You could actually write down equations and predict exactly how a machine was going to move. This gave us the foundational blueprint for a robot's body. The first piece was in place.
All right, so we've got the blueprint for a body. But a body without a mind? That's just a puppet on strings. The next great revolution, the next piece of the puzzle, was all about giving that machine a brain. Something that could calculate, process information, and, actually make its own decisions.
And for that, we have to go back to the 1830s and meet the grandfather of the modern computer, a guy named Charles Babbage. He dreamed up this incredible thing called the analytical engine. It was basically a thinking machine made entirely of gears and levers. Now, it was way too advanced for the technology back then, so it was never actually built. But the idea, wow, it was totally revolutionary. A machine you could program to solve pretty much any problem.
And you can't talk about Babbage without talking about Ada Lovelace. If Babbage was designing the hardware, she was basically writing the first software, 100 years early. She was the one who realized his engine could do so much more than just crunch numbers. She came up with ideas like subroutines, little reusable chunks of code, and imagined a machine that could handle any kind of symbol, maybe even compose music. The idea of a truly programmable brain was officially born. It just had to wait a century for the technology to catch up. And man, what a leap that technology had to take. We're talking about going from Babbage's complex, slow-moving mechanical gears all the way to this beast, the ENIAC, in 1946. This was it, the world's first real electronic digital computer. It was massive, filled with over 18,000 vacuum tubes, and it could finally do the lightning-fast calculations Babbage had only dreamed about. The robot officially had a brain.
There was just one problem. The ENIAC was the size of a huge room. So we needed one last piece to the puzzle, and that was the microelectronics revolution, all thanks to the invention of the transistor in the late 40s. This was the game changer. It let us take that massive room-sized brain and shrink it down, way down, onto a tiny little chip. Suddenly, the brain was small enough, cheap enough, and powerful enough to actually put inside a machine that could move.
So there we have it. After thousands of years of dreaming and a few centuries of incredible science, the moment had finally arrived. You had the mechanical body, built on the laws of Newton, and you had the electronic brain, born from the transistor revolution. They were finally ready to be put together. It's kind of funny, the name we gave these things, robot, actually comes from a Czech play from 1920, and the word itself, robota, means forced labor or servitude.
That tells you pretty much everything you need to know about what we wanted them for in the beginning, right? We wanted them to serve us, to do the jobs we either couldn't do or, let's be honest, didn't want to do.
And one of the very first big jobs we gave them? Exploration. Back in 1970, a full 6 years before that Viking lander touchdown on Mars, the Soviet Union's Lunokhod 1 rover was already rolling across the surface of the moon. This thing, this remote-controlled vehicle, was humanity's first ever mobile robot on another world. It was that crucial first step that really paved the way for all the Martian explorers that came after.
Meanwhile, back here on Earth, another purpose was taking shape. A man named Joseph Engelberger, who is basically known as the father of robotics, had this great idea. He said, we should use robots for any task that's dull, dirty, or dangerous. And that simple idea, it fueled the entire rise of industrial automation. Suddenly, robots started transforming factory floors, taking on all those repetitive, hazardous jobs.
So you had these two huge starting points, right? Exploring the great unknown and automating tough labor. And from there, the world of robotics just exploded. Those foundational ideas have branched out into pretty much every field you can possibly imagine.
I mean, just look at the incredible range this shows. On one side, you've got robotic telescopes staring out into the deepest parts of space. And on the other, you have autonomous vehicles mapping the deepest, darkest trenches of our own oceans. From the absolute heavens to the abyss, robots have truly become our eyes and our hands everywhere. And today, it's everywhere. We've got robots assisting in surgeries with a precision no human hand could match. We have them cleaning our floors. They're venturing into disaster zones that are way too dangerous for people. We're talking about everything from nanorobots the size of a molecule all the way up to drones patrolling our skies. That ancient dream of a machine that moves on its own, it's here. And it's a reality in thousands of different forms.
Which brings us all the way back to where we started, with that original meaning of the word robot, servitude. For centuries, we dreamed of building machines that could serve us. Well, now they're here, and they're getting smarter and more capable literally every single day. The long road to the robot isn't over. It's just brought us to a new crossroads. And it leaves us with a really big question. What is our relationship with these machines going to become?